Hello all. So today we will be discussing question number 12 from TIFR paper, 2020 paper. So this question is basically a question on complex numbers, all right? And you just need to understand a little bit of equations to understand what is actually going on. So the first hint that this problem throws at us, if you look at the problem, then it's if zeta is a set of 7 complex numbers with unit modules, assume that they form the vertices of regular heptagon. So the moment it says this, that assume that they form the vertices of regular heptagon, and these are of unit modules, what do you say? So let's say, what should we take from these two things? That unit modules and vertices of regular heptagon. So the moment these two things are actually given, what does it mean geometrically? Geometrically, it means that the zetas that you are taking, these are up to some rotation. They are the uh, roots of unity of x to the power 7. All right. So if x to the power 7 is equals to 1, then these are the roots of the unity, basically, up to some certain rotation, because vertices of regular heptagon. Thus, what happens is that each of these zi's, so each of this, let's say, if I write zj, so if each of these zj practically looks like this, with a little bit of rotation of and e to the power 2 pi I by 7. All right. So where this t, it is something that we have fixed from R. Okay, so belongs to R is fixed. So the first thing to notice here is that since it is these are our unit modules and vertices of regular heptagon, all of these zj's, if you take j away from 0 to 6, all of these have to be of this form. So this is the rotational variant, and this is the unit, the roots of unity part. Okay. So what happens if you take this? So what practically is being given to you is that what will be the summation of zj, zk, j less than k. So that's the summation that we will be trying to find here. Now, what is this? If you look at it closely, if you take this half into z less than k, 2z j z k. So this is practically is nothing but with a form like this. Okay, so it's basically some zi whole square minus zi's square. All right. So it practically will look like something like this. I equals to 0 to 6 minus zi square I equals to 0 to 6. So why is this happening? It's because of a very uh, I mean, strategic observation. If you look at this, let's say for 1 and 2, if I fix at my 1 and 2, j and k, if you take 2 z1 z2, so how can we actually find it out? So you can actually find this one out by z1 plus z2 whole square minus z1 square plus z2 square. If you take 1, 2, 3, then you have z1, z2 plus z2, z2, z3 plus 2, z1, z3. So what will it happen? So you will have this z1 plus z2 plus z3 whole square minus z1 square plus z2 square plus z3 square. Okay, so this is practically, with mathematical induction, you can actually prove that. With mathematical induction, you can prove that if you take zj, zk, then this will be the answer. Okay, so if I have taken half common and multiplied by 2. Now, since we have a very specific ways of zj in our disposal, so what we do, so we will just put them here. So just putting, so let's say putting the value of zj in, let's say, let's call this as equation 1. Okay, so putting the values of zj in equation 1. So then what do I get? So I get something like this: e to the power 2 it by 2 into 2 w. So did I take something like this? So let's call this, since these are the roots of unity, let's just call them as omega. So then omega to the power j, omega to the power k for j less than. So this is what will happen if you just put down the zj's value. So if you put down the zj's value here and here, then they are practically e to the power it into omega to the power j, and so yeah, so of course, since we are taking zj, there's a small typo that I have actually done here. Sorry for that. So it's basically like this. So if this is omega, let me write it down somewhere. So then zj really looks like sum to the power g. So e to the power 2 pi I to the power g. So this is the omega j part. Okay, because since it is the jth seventh root of unity. Okay, so that's how it pans out. All right. So now, if I have this, then what basically happens? It is practically following this rule. So then you have something like this in your hand: e to the power 2 it by 2, then summation over omega to the power j whole square, j equals to 0 to 6. So omega to the power j whole square, this one, as you can see, like 2 z1 z2, it is z1 plus z2 whole square. So here you will have omega 1, omega to the power 1 plus omega square plus dot 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 dot, dot like that. Okay, so this minus summation over omega to the power 2j, j equals to 0 to 6. Okay, so this is coming from this, just this formula. We are just applying this formula. So if you take this, then what is this? What is the first part? The first part is just the summation of the seventh roots of unity, 1 plus omega squared till omega to the power 6, and hence this entire term goes to 0. What about this term? This is nothing but 1 plus omega square plus omega to the power 4 plus dot 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 plus omega to the power 12, right? Now, sorry, omega to the power 12. So now, after omega to the power 6, what will happen? After omega to the power 6, you will have omega to the power 8, omega to the power 10, omega to the power 12. This is how it pans out. So after this, you have 6, then you have 8, then 10, then 12. So this is the entire span. All right. So this is the entire span. But now omega to the power 8 is what? If omega to the power 7 is unit, I mean like 1, then omega to the power 8, this is omega, this is your omega cube, this is your omega to the power 5. So as you can see, this entire summation is nothing but also summation over omega to the power j equals to 0 to 6. And hence this goes to 0 as well. Thus, both the segment of this summation goes to 0 individually, hence the entire sum is 0. The answer is that the entire sum is 0. So that's what we have as an answer. And that's what is the summation of this? The summation of this is 0. All right. So the way we proved it is, the first thing you need to establish is that this has been given as unique modules and vertices of regular heptagon. So that is the reason we were able to write each zj as e to the power it omega to the power j, where omega was the 7th root of unity. So the jth uh, so the jth 7th roots of unity will precisely have this type of form if a rotation is involved. And since we are talking about regular heptagons vertices, all these are points up to certain rotations. And from there, we derive it with the very usual formula of summation. So that is it for today. So we will meet with another problem in the upcoming days. Thank you. Yes, Sanket, the answer is 0. Well, thank you for joining us. We will meet with another problem in the next